Hello everyone, welcome to the course on Artificial Intelligence in Industrial and Management Engineering. I am Dr. Prabal Pratap Singh from IIT Kanpur. In the last lecture of this course, we have covered the foundations of what is learning in artificial intelligence systems, then different kinds of learning like inductive learning and deductive learning, then when to use inductive learning and what are the challenges of implementing a deductive learning systems, right. So, we have created the foundations of what is a machine learning system. Most of you may have already guessed that machine learning systems are usually inductive learning systems, right. So, we will now start learning the basics of what is a machine learning system, and the agenda for the today is, first we will try to introduce what is a machine learning system. Then we will see what are the applications of these machine learning systems in industrial and management engineering domain. Then we will, similar to the types of learning process, we have different types of machine learning processes as well. We will try to see what are the differentiations between those. Then we will dive deeper into supervised machine learning like classification, regression, reinforcement learning, and then we will learn briefly about unsupervised learning as well. Finally, we will try to discuss about a complete roadmap of creating your own machine learning systems by like when you try to identify various patterns in your data set for a particular application, then you need to know what are the milestones that you need to cover to create a workable systems in machine learning. Okay. So, let us start from understanding what is machine learning. So, machine learning is nothing but machine learning is the science and applications of algorithms to make sense from data. Okay. So, this is the science and applications of algorithms, and what we need to do is we need to make sense from the data. Okay. Now, data is in abundance. So, in current scenario, we have already created systems in our real world where we are capturing different kinds of data. For an example, when you use a web browser in your laptop, tablet or mobile, when you are trying to move the cursor, even that gets stored somewhere in the browser to identify what is the behavior of the user. So, these kinds of systems where we are storing these data of moving our mouses and where the user is going from one button to another is very useful for e-commerce websites as an example, right. So, we can easily state that data is in abundance these days, right, and from that abundant data we need to create knowledge. So, machine learning is using algorithms we can turn this data into knowledge. Okay. Now, how to build these intelligent machines? Which intelligent machines that can transform these data into knowledge. Okay. So, we have large amount of structured or unstructured data, right, and machine learning has evolved as a subfield of these AI systems. So since these machine learning systems has evolved, so machine learning systems has self learning algorithms that can turn this data into knowledge. So when we were talking about inductive learning systems, we were saying that the system gets the power of creating its own rules, right, by seeing the observations. So that is what we were trying to say at that time, that these machine learning algorithms have self-learning, machine learning systems has self-learning algorithms that can turn this data into knowledge by creating their own rules. Okay. So this, and when we see new observations into a system, then we can predict what kind of data we have just observed by utilizing the already created rules using these kinds of self-learning algorithms. So these knowledge can be used for predictions. Okay. So previously humans tend to derive these rules and build models from large set of data. So earlier we were trying to do these systems by creating our own pre-specified rules, right? But now machines can do this rule development efficiently, can do this operation efficiently using self learning algorithms. So ML is playing crucial role in our daily lives. Now some of these crucial roles are like better email spam filtering, or efficient voice recognition softwares slash devices like Alexa, Siri, more improved web search engines, better recommendation of movies or things to buy, like the for an example movies slash music. So for an example, Spotify has a very evolved algorithm for recommending new music to its user, or the estimation of delivery times. So every time we try to order something from the internet or e-commerce websites, the delivery times that we are seeing in our invoice or on our on these websites, they gets easily estimated beforehand, so that the user can be prepared when the delivery gets arrived. Okay. So, these are all the applications of machine learning algorithms. So, one more example is like medical applications like skin cancer detection or 3D protein structure predictions. So, these kinds of problems come into deep learning, and we will also touch upon these topics in this course, and these are highly active research areas in this field. So, the medical applications like skin care detection, these are all the requirements of various medical domain persons, and most of the researchers are trying to create well evolved systems so that these kinds of problems uh, gets easily solved. Now, let us come to the applications of industrial and management engineering domain. Okay. So, machine learning algorithms can automate repetitive engineering tasks like production schedules. So, in every factory wherever production is being performed, they create different kinds of schedules for the laborers and the different kinds of workers. So, these kinds of production schedules can be easily automated by these systems. Okay. And this can be attributed to the enhanced efficiency of the complete system. So, ML algorithms can enhance the efficiency of these systems in these industrial settings. We can also can perform real time anomaly detection and this can reduce defect rates in the products. So, these kinds of systems can be used in quality control of the complete production systems. Further, ML algorithms can also foresee equipment failures or minimize unexpected downtime, and what this will do is it can overall minimize the maintenance cost. So, it can also be useful for predictive maintenance. These algorithms can also detect inefficiencies in logistics and inventory management. So this can be attributed to supply chain issues. It can also perform real time data analytics that can help make informed decisions. So this can be attributed to improved decision making. So these are some of the broad categories where we can utilize machine learning algorithms in industrial and management engineering domains. Like we can increase the efficiency, we can utilize better quality control in our systems, or perform predictive maintenance, improve our supply chains, and can utilize them for improved decision makings at various levels of the decisions that needs to be taken inside a factory or a production system, right. So out of these few things, we will try to dive deeper in the next few weeks, so that we can understand how to develop these systems and perform different kinds of analysis in these systems. Next, we will try to understand what are the different kinds of machine learning techniques that we can utilize to develop different systems, right. So there are majorly 4 kinds of systems. Different kinds of ML systems. The first one is supervised machine learning system. Second is unsupervised. Third is reinforcement learning, and the last is semi supervised. So let us try to look one by one in each of these different systems. So supervised learning is nothing but we have some input data and we try to identify the labels for that input. Okay, it is also known as label learning algorithms. It is a process of modeling the relationship between input and their associated output labels. So these are nothing but output that we think. So for a supervised learning system, we can further categorize into regression and classification system. Okay, these are 2 subcategories of supervised ML systems. Okay, now what is classification? When labels are discrete, that is the output is discrete, then we will term those systems as classification problems. And regression is nothing but when labels are continuous. So let us take a step backward and try to understand what are the different kinds of data types that we may get and we may encounter in our machine learning systems. Okay, so data types can be broadly classified into quantitative and qualitative. So quantitative has two more broad classifications as continuous and discrete. Continuous can be further divided into interval and ratio. Whereas let us come again to qualitative data types. We have only three different classifications, sub-classifications, namely nominal, ordinal and binary. Now let us understand these one by one. So the first one is, let's start from here, ratio. So an example of these kind of data types is your height, okay, or weight. So they have a we have a clear understanding of what is a zero height and what is a negative, what is a positive, right? And we can also take ratios of these. So we have a meaningful zero and a meaningful difference in these kind of data types. Whereas in interval types, there is a meaningful difference, like an example of this is temperature. So let's say you are measuring a temperature in degree Celsius. So let's say you are measuring temperature in degree Celsius. So you know what is the difference between 80 degree Celsius and 100 degree Celsius, but what is 0 degree Celsius? So that is why there is no meaningful zero, but there is a meaningful difference in these kinds of data sets. Okay. Now coming to discrete type of quantitative data set, good example is whole numbers like number of students in a class, okay, or number of cars. So you cannot take ratios of number of students, like there are 30 students, 40 students, you cannot divide those numbers, okay. So that is why these are just the count of a particular quantity. So that is how discrete is different from continuous, but they are both quantitative data sets. We are talking about some quantity, but qualitative data set is something different, like starting from nominal can be your eye color. So eye color can take only categorical values, like eye color can be black, brown, blue, green, something like that, okay. So there is no difference that you can quantitatively count or take difference of, okay. So these are nominal data type, whereas ordinal data types are something like your movie ratings. So let's say you are looking at the IMDb website and you have a scale from 1 to 10. So you don't know what is the actual difference between giving a movie a rating of 5 and 7. Yes, you can difference by giving, yes, you can say that there is a difference of 2, but what is the quantity of that 2? So it is not clearly defined. That is why these types of data types have imprecise difference, okay. and binary is simple. You have just given class of 10 students a form to fill, and it contains only true and false questions. So, the data you will receive will only have either true or false. So, these are the different kinds of data types. And for a particular data type, we have different kinds of machine learning systems. So, that is why we have introduced these kinds of data type, because when we are talking about classification systems, we are talking about identifying the labels which are discrete. So, what are the discrete labels? These. And in regression, our output variable will be continuous. So, either it will be interval or ratio. So, let us stop here today, and we will continue learning more different kinds of machine learning systems in our next class. Thank you.